My focus has been on experimental fluid mechanics, and I've sort of branched out from there significantly, looking at computational work. As a result of a discussion, I ended up getting interested in looking at sprays, and that discussion was with a colleague in the department, Nasser Ashkars. We were interested in the same sort of thing, but we were coming at it from slightly different perspectives. Mine was more the turbulence aspect, his was more the spray. And we started to look into this, and we were lucky to have a very talented postdoc who worked with us, Sami Reza. And as a result of this, we were able to put together what is the first step to a company, Maslite.
I started my work on sprays probably about 40 years ago on application of spray combustion in fuel injection systems, especially for Air Force applications in jet engines. And it just continued from there, looking at droplet combustion, spray formation, and now, once we see the wide applications of the spray, we've extended it to from hairspray to rocket engines, anywhere that droplets and sprays are used. The system that we have is designed for industry to be able to characterize their sprays. It's simple to use, relatively inexpensive, and it can be implemented directly in the industrial processes. We are hoping that this can change the way industry looks at and designs sprays.
The problem that exists today in the spray industry is that there are a lot of nozzle sprays that people can choose from, anywhere from people who deal with mass spectrometry all the way to agriculture, all the way to pharmaceutical where they're producing powders or they're coating their tablets, to food industry, to automotive paint. Some of the folks that we dealt with in various industries, they're looking for understanding the process and understanding really how to develop their nozzles. So, for example, in aerospace, the quality of the nozzle is quite important. It affects the bottom line of an airline where you have combustion and combustion efficiency. Everything gets tied back to fuel atomization. Our instrument is based on imaging. We're also using a lot of computing power that wasn't available years ago to analyze these images. We help them out in 3 ways. We help them first identify what nozzles they should be using that will generate the outcomes they want. We also help them how to optimize those nozzles so it behaves the way they're expecting it to behave. And also, ultimately, we're trying to help them run a facility where this is a continuous production and they're able to continuously monitor and maintain that level of quality.
So one of the advantages of working with CMC is that Canada is a big place, there's lots of expertise, but there's no real centralized repository like CMC available at the university or in any other sites. In order to develop a commercial product, I need to have some outside input that assists in understanding the validity of our product, and that's what we got from CMC.